the coordinate plane, right? So we're going to start on today's lesson. We're going to get it over with, and then we'll look at our test grades at the end of class, and we'll correct what we got wrong, okay? We're going to dive right into our new unit, which is called coordinate geometry. So let's just see how much we know. Let's see how much we know about this picture right here.
Y and X.
All right, Jacob, you go first.
Oh, Y and X.
Which one's Y and which one's X?
Y is top, X is bottom.
How do you remember which one is which?
From
Do you have any?
Yeah, from the previous unit.
Right, but do you have any like tricks or anything to remember which one's the Y and which one's the X?
You remember it.
You just remember it?
Yeah.
Okay.
There's
I feel like the algebra teachers had like a trick or something.
Nah, mine
Just
didn't.
remember. Do you know, Trent?
You run before you jump.
Oh, okay, that's when we get into slope, or plotting a point. Very good. Because when we plot a point, you can't go up and then over. You have to run first and then jump. So very good, very good. All right, let's talk about where X is positive. Well, no. Let's name the quadrants. Who can come to the board and name the quadrants? Like, I'll do the first one for you. I'll put a Roman numeral number 1. You want to finish me off? All right. Thank you, Jared. You got this.
Which one's the side or bottom?
Well, that's what you're telling us.
I'm just gonna assume.
You don't assume anything. Oh, I thought you were going to finish us off.
Oh,
1, 2. Where's 3 go?
I don't want to take all the credit.
Oh, my goodness. Okay. So, that's quadrant 1, quadrant 2, quadrant 3. And how do you write a Roman numeral 4?
The
A
I.
1 or an I, and then the V. Okay? So label your picture. Do it right now. Label yours. 1, 2, 3, 4. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. It goes in a, is that clockwise or counterclockwise? Counter. That's the opposite way that the hand goes on the clock. Not that y'all did like normal analog watches. Is that what it's called, analog? Versus digital? You do. I like it. Very cool. All right, you do too. Good job. What do you not have digital? But you mainly use your cell phone, right? To check the time. Anyway, so it goes in a counterclockwise rotation. 4 quadrants. Starts right here. You have a little table on your sheet of paper, and it wants you to fill out where X is positive. Where is X positive? So what quadrants is X positive? Quadrant 1, definitely. And quadrant 4. Very good. So go ahead and write those down. It's positive in quadrant 1 and quadrant 4. And where's X negative? The other 2 that we didn't name.
3.
3. Yeah, let's do 2 and then 3. Quadrant 2, quadrant 3. Chris, where is Y positive? It's all of this. This is where Y is positive. Which ones are those, Chris? 1 and 2. And Betty, where's Y negative? 3 and 4. 3. Alright. So we named them. We said where they are. Now we're going to plot a point. And we're going to do exactly what Trish said. We're going to walk or run before we jump. So when we plot that point, thank you, ma'am. Good thing this is a review. We all know how to do this. Plot the point 3, negative 2. So 3 is our X, and negative 2 is our Y. So on the X-axis, we're going to go positive 3. 1, 2, 3. And then we're going to go down 2. Negative 2, 1, 2. So we would put that, and we would call it A. So go ahead and plot that point. Over 3, down 2. Is to walk before you can jump. And call it A. Alright, go ahead and plot B, C, and D. And I'll have you come to the board and put those points on the coordinate plane as I call your name. Jessica, go plot B on the board. Zaya, oh, you just got here. Renad, go plot C on the board. And DJ, do D. Jessica, Renad.
What else you think? Algebra? Yeah.
How come you know me?
I'm sorry, what?
How do you know me?
Like we're following his paper?
Oh, yeah.
No, expression.
Oh, because.
Did you say there's no such thing as expression?
These are all the other ones, right?
No.
So, like,
Negative
what
5.
if
Did
there's
you have, wait, y'all didn't label them with letters, guys. I am so confused because you left your points naked. No clothes on your points. Go label it.
I only got two ready.
Where's your point? Oh, right here? Put the letter, who put the blue? Oh my goodness, people. Right. There, that's where the letter goes. It goes right by the point. All right, let's see. B, -5, 7. So you go backwards 5 and then up 7. That looks good to me. C, -6, 1. So we need to go backwards 6. 1, 2, 3, 4, 5, 6. And then up 1. So that's where C goes. And then
Oh,
D
no.
is 0. Go 0. And then go up 9. Okay?
That's 8.
Yeah, that's wrong. That's 8, not 9.
Oh, you didn't count exactly 9? Heavens, guys. Okay. A, B, C, D. Ask me a question.
What's your favorite color?
Because in this unit, if you can't plot where the point goes, then you definitely can't find the slope or the distance or the midpoint. You have to be able to plot them. All right, can we go backwards is the question.
Yup.
If I plotted it, can you say the coordinates? Go ahead and try it, and then I'll call on names. Write down the coordinates of A. Write down the coordinates of B. Oh, Chris is already on the back. He's like,
Done.
too easy. Jose, go write the coordinates of A, and Alexa, go write the coordinates of B. We need a protractor for these, by the way. Oh, okay. So this will match this, whichever one. Like, which one do you think about? This one where they're equal? Then did you put them together in one like this? You know what you said? Oh, yes, the X has to be right. Yes, it- Three, and 7, 9. Beautiful. All right, we got this. That was all positive. That was nice. Okay, flip it over to the back. Keep naming points. Go ahead. A, B, C.
D and E. Don't call me.
You already have them done. Why wouldn't I know?
No.
Claire, you're going to do A. Lillian, you're going to do B. And Elijah, you're going to do C. Okay. Sorry. I put an extra E in there. Sorry, I was giving you a bonus E.
That's wrong. What the?
Not in
A,
there.
3, 5, check. B, 3, -5, check. And C, -5, -1. Any questions? This is easy as Tanton.
Yeah, no, I got it.
All right, keep going. PQR.
Is R supposed to be on the y-axis?
It looks like, let me see what my key is. It looks like it's at -0.5. Are y'all getting that too? Let me See how it's not perfectly on the y-axis?
I put 0.
Done.
You put 0. Trying to see what I put. Zaya, go do P. Jacob, do Q. And Araceli, do R. And R looks like it's not exactly on the 0, but we can talk about it.
Pretty sure that's right. It's close.
Negative. Cool. Alright, so P is at -2, +5. Looking good. Q, 5 down 2. Looking awesome. R, I really like what Araceli put. -0.5, because it really does look like we went 0.5 that way. 0.5 is half. We went halfway this way, and then down 1, 2, 3. Down 3. Down means negative, so that one did mean to be negative. Okay? You can put the 0 in front, or you could put -1/2 like that. You could have put that. Okay, we are almost done. Are we done with that worksheet? No, there was one more.
Hey, we talked about world history.
Pythagorean. Name the line that contains the following points. Okay, go ahead and do that one. Yeah, they're blue on here. I don't have color printed. Jared, which line contains H? Point H. So if you go -2 and then up 7, what line are you on? Oh, you're going to come right up. E, very good. Ruthie, what about I? I can write it for you. What? Do it. Which line does I fall on? Negative.
Oh, I thought I got it like that.
7, 8. Yep, B, very good. Betty, what about J? Oh, she was ready to go. C. And Jessica, what about K?
I'm so lost.
Okay. Jacob is lost. Okay, so what you do is you plot this point, -7, 0. We already plotted a lot of points. So you go 1, 2, 3, 4, 5, 6, 7, and you go up and down 0. You put that dot on your graph, and you say, hey, which line is that dot on? Oh, it's on this line. What's that line called? It's called A.
Oh.
See how each line has a little lowercase name to it?
Yeah.
Okay. Alright, well we are actually done with that part. We're going to move on. Now that we have reviewed the coordinate plane, we're going to review another thing. And you're going to like it because students are always good at this next thing that we're going to review.
Wait, but we don't like reviews.
It kind of is. And what do you think the theorem is that we're about to go over? If I have that slide. Pythagorean Theorem.
Oh my god, it's just thick.
I know.
Sorry, it's a long unit.
We need trees on the die for this. What's these iPads? We have like 700 of them apparently.
But you can't take them home with you and study them.
Yeah, you can. If I take the tracker out.
Study them on
Alrighty, Pythagoras lived in Greece in what? In the 500s BC. What does that mean?
Before Christ.
Before Christ. Yeah.
I think that's when you go
That's
back.
a long time ago. That's on my list to go get more. He's known as the father of numbers because he discovered a lot of math things.
What are they?
He's technically, they gave him the credibility of discovering Pythagorean theorem, but then they found that it was used even earlier in Egypt by the Egyptians, even in 2500. So anyways, this theorem has been around for a long time. If they figured it out in 2500 BC, then how long has it been around?
2,500 years before Christ.
2500 plus, what year are we in?
2027.
So how long has it been around? 4,514 years. That's a long time. for a theorem to be around. So it is tried and true. That means that it works, and it always works, and we use it a lot. All right, so what makes these right triangles? What is a right triangle?
The square.
The square. A right triangle is a triangle with one blank 90-degree angle. Oh, sorry. We're going to put with one angle. This is in your notes. It has one angle which measures 90 degrees. Does it have two angles that measure 90?
No.
No, one angle, because you can't have two angles that measure 90, by the way. One angle which measures 90 degrees. What are the parts of a triangle? A right triangle, rather. What are the parts?
ABC.
There's a leg, ABC, and there's a hypotenuse. So if I were to try to locate the hypotenuse, do you remember what that is?
This is the longest part.
The longest side. How would I know for each one which one the hypotenuse is?
The longer one.
So here's how you tell. Are you listening? You draw an arrow away from the box, and that is pointing to your hypotenuse. You draw an arrow away from the 90 degrees, and that's your hypotenuse. Away. Hypotenuse. You get the idea? Away. That's the hypotenuse. Away. There's the hypotenuse. Because sometimes it's hard to tell which one's the hypotenuse. I know it's the longest one, but what if you don't have a ruler and you don't know which one's the longest? If you always draw an arrow away from the right angle, you will be pointing to the hypotenuse. Elijah, can you go to the board and drag those words to the correct side? Drag this to which one's a leg, and then drag the word to the hypotenuse. So a right triangle is always going to have two legs and one hypotenuse. The legs are not necessarily going to be the same length, but they are both called a leg. The right triangle has two legs just like we have two legs. Now put it on a side, not an angle. On a side. You can use your knuckles sometimes. See, much better. Okay. Let's do an angle. A side. The sides are the legs. There you go. Sides. Okay. Okay. Yeah. I'm just gonna move right here. Leg. Hypotenuse. Okay. Good. So this is a leg. This is a leg, and this is the hypotenuse. So, where'd my cards go? So, Renaud, come label one of these two triangles. All I want you to label is the hypotenuse. And Jose, label the other one.
Birthday boy.
Birthday boy. DJ, your card was up. I didn't want to make you get up again. Leg, hypotenuse. Very nice. Thank you, ma'am. Very nice. Thank you, sir. Did you fill in your notes? Leg, hypotenuse. You got that?
Oh, no.
Leg, and then hypotenuse in those boxes. Yep. You may be right, Pythagoras, but everyone's going to laugh if you call it a hypotenuse.
I don't know.
You see what's it called, the key and field thing with hypotenuse?
Oh, no, I haven't.
They made fun of it because it said, I'm high on pot news.
Oh, maybe that's not school appropriate. I was going to say I should look that up, but I don't think I can show that. Okay. He's laughing. Doesn't it sound like the laugh that guy would have? Anyways, okay.
Oh.
Hypotenuse, they're just laughing because it's a weird word. Hypotenuse. Everyone say it.
Hypotenuse.
Hypotenuse. All right. So here is the Pythagorean Theorem. You've seen it. You know it. But today we're going to make sure we remember how to use it. So Pythagorean Theorem is a squared plus b squared equals c squared, where c is always the hypotenuse. C is always the hypotenuse. And then a and b are the legs, but I don't care which one is which. I don't care which one's A and which one's B. The legs are interchangeable. Because do you agree that 3 plus 2 equals the same thing as 2 plus 3?
5.
Yeah, it equals 5 either way. So A and B are interchangeable. But C is not interchangeable. You have to get C right. Okay?
Not easy, kid.
We're not going to get out manipulatives or anything like that, I promise. But I just wanted to show you how Pythagoras, like the visual of how it works. When you square something, like when I say go to your calculator and and type in 3 squared, what are you going to get? You're going to get 9. Very good. Now, what that means is you're taking 3 and you're squaring it. When I say you're squaring it, you're literally making a square. How many cubes are in this square? 9. Because it's 3 by 3. 3 squared is 9. It's a square made up of 9 little squares. Does that kind of make sense? So what's cool about this is that 3 squared is 9, 4 squared is 16, and 5 squared is 25. You could fit his squares and his squares into the purple one. They would perfectly fit. That's how Pythagorean Theorem works. It's just kind of cool visually how it works. So if I took these, I think this works. Ready? I'm going to take his squares. Oh, not that one. I think I wanted. And it can fit perfectly into here. Here we go. This is what I wanted to. So there's the pink. And here's the lime green. Oh, there we go. See how they perfectly fit? This plus this equals that one. They fill in perfectly. And that's how Pythagorean Theorem works. No, it's just good to have a visual. We're actually going to skip that one. All right. Let's do it. Let's dive right in. Let's solve for some missing signs. Find x. So the first thing we're going to do is we're always going to write an equation. That is always what we're going to do first. Ruthie, can you tell me an equation to solve for x?
3 squared plus 7 squared.
X squared. Very good. So that is your equation. Your equation is not a squared plus b squared equals c squared. I want you to actually plug the numbers in. 3 and 7 are our legs. So those are our a and our b. It doesn't matter which is which. 3 squared plus 7 squared equals x squared. Okay, I want everyone to go to your calculator and type in 3 squared plus 7 squared. Do you know how to square something in your calculator? It's the button right below the math. It's 2 below the math button. It looks like this, x squared.
I found the answer.
DJ, what is 3 squared plus 7 squared? Okay. 58 equals x squared. Now wait a minute. I didn't ask you to find x squared. I asked you to find x. What is the opposite of squaring something? Square rooting. Remember that? Yeah. So to solve for x, you have to undo what's being done to him. He's being squared. You need to undo that. The way you undo squaring is square rooting. Can you find that on your calculator? You have to press second x squared, because it's actually the inverse of x squared, which is so cool. You're undoing it. So everyone needs to square root 58 right now. Every person in this room needs to square root 58 to show me you can do it.
7.61.
Now what does it say to round to?
Nearest.
Nearest 100. Now, if you had $100, how many zeros is that?
2.
2 zeros. So that means we're rounding it to 2 decimal places. So we're going to get 7.6.
1. Oh, 2.
Oh.
So 7.615. Here's 2 decimal places. He consults his neighbor. He says, hey neighbor, what should I do? Should I stay the same or should I bump up? And the 5 tells him, bump up. Because everything 5 and bigger bumps the number.
So
7.62 is the final answer. That is what x equals.
What did I get?
7.62. Yeah, if you got something weird, we need to fix it now. You squared 58 instead of square rooting. Second x squared. That's not square root. Thank you for asking. No, that's important. Moving on. Claire, what's the equation for number 2? Oh, sorry, say it louder. Okay, let's all do this. From now on, I want you to always draw an arrow away from your box and circle it. That's your C every time. Draw an arrow away from your box and circle it. That's going to be your C every time. Ready, Claire? A squared plus B squared equals C squared. Squared. There you go. That's your equation. A squared plus B squared equals C squared. Now, don't you dare type the letter X and then squared in your calculator. Please don't type X into your calculator. Let's square the things that we can square. What's 5 squared?
The answer is
25.
0.65.
And what's 19 squared? What?
361.
Thank you, sir. Now, wait a minute. I need to get x all by itself.
19.64.
Just a
five,
minute.
five.
The way to get x all by itself is to do the opposite of what's being done to it. What's the opposite of plus? Minus. So we need to get that 25 over to the other side. We need to subtract 25 from both sides. X squared equals, what's 361 minus 25? Good thing we have calculators, huh? X squared equals 336. Is that my answer?
No.
No. What's the opposite of squaring something?
Square root.
Square rooting. My Relly, what is the square root of 336? Thank you. Round to the nearest hundred, so 2 decimal places.
We gotta prove this.
No, square root of 336. Okay, 2 nearest hundredth is 2 decimal places. Very good. 18.33 is the final answer. Hey guys, did you notice how in the last problem we added, and in this problem we ended up subtracting?
Because of 19.
So, let me just give you a little hint. When you are looking for, let me get a new slide. When you're looking for the hypotenuse, you're going to add. When you're looking for a leg, like when a leg is x, you're always going to subtract. And that will help you solve these problems a little bit quicker.
No, wait.
What? Find the length of the missing leg. So can I just show you real quick what you could do to skip a step here? Are you looking for the hypotenuse or are you looking for a leg? We're looking for a leg. So actually, I would not mind if you just put your equation is 15 squared minus 11 squared. Because I know when I'm looking for a hypotenuse, I add, and when I'm looking for a leg, I subtract. And that might make it less scary because you're not going to have to move stuff around. So everyone go to your calculator and do 15 squared minus 11 squared. Jessica, tell me what you get. What's 15 squared minus 11 squared?
I got this.
Come on, get down. Squared minus 11 squared. 104. 104 equals x squared. Trent, what is the square root of 104? We're going to round it to 2. What?
I don't know if they're
Oh, thank you for asking. Dad told me these things. Okay, so square root is right above the x squared. So second x squared. And 104. What you get? Ooh, guys, this one's tricky. Did you see this? What does the calculator give you? 10.19. Ooh, that's bad. Because this is the nearest hundredth. But he asks his neighbor, do I stay the same or do I bump up? What does his neighbor say? Bump up. How do you bump a 9 up?
So,
Uh-oh. It's going to be a 10. So that's actually going to bump this to a 2 and a 0. Because what comes after 19? 20 does. So the answer, that was tricky, is actually 10.20. 10.20. Uh-oh. A word problem. What are we going to do? Jared, can you read this problem out loud, please?
to get to school each morning, Cammy drives 5 miles shorter and then 8 miles west. Well, north, not shorter, my bad. A total of 13 miles. How much shorter would it be? Would she travel if she had a helicopter and traveled in a straight line to school?
Cool. I think I have sound. The helicopter flying over our class. She's flying to school because she's rich. Okay, anyways, so we need to draw a picture. Don't you dare solve a problem like this without drawing a picture. So, everyone put a dot on their page. Put a dot. That's her house. Put a dot. Everyone put a dot. She drives 5 miles north. Which way is north?
Up.
Up. So I want you to go up, put another dot, and label that 5. That is 5 miles. 5 miles north. 8 miles west. Point with your arm. Is west this way or this way? This way. So go 8 miles. 8 miles west. Yours should look like mine. 5 north, 8 west. So this one, I'm going to put H. This was her home, and this was her school. Now, one day she was running late, and so she didn't want to drive up 5 over 8. She wanted to fly directly to school. So it's asking how much time is she going to save by going directly to school and not having to drive along the road. Does that make sense? What we're going to do first is, Claire, tell me how far she travels if she goes by car. How far does she travel if she goes up 5 and over 8? 13. Is everyone okay with that? 5 plus 8 is 13. So she travels 13 miles if she has to get her car out. Now we're going to find how many miles she travels if she gets her helicopter out. How are we going to do that? Betty, set me up an equation. How are we going to find X?
5 squared plus 6 squared.
Beautiful. Pythagorean Theorem, because it's a right triangle. Because if you go north and then you go west, you make a right angle. You already have the answer. Very good. Jacob, what is X?
9.43.
So we did 5 squared plus 8 squared in our calculator, and then we take the square root of that. So that's the opposite of squaring. So square root of 89. Square root of 89 is what you should have done. So if she takes the helicopter, she travels 9 miles. If she takes the car, she travels 13 miles. How much shorter was it to take the helicopter? How much shorter? How many miles did she save? You can just use the whole numbers. 13 and 9. Whole numbers. 13 minus 9. What? She saved, the answer to number 4 is 4. She saved 4 miles by getting in her helicopter. Has anyone ever ran 4 miles? Any long distance runners?
No. I like to
Oh, guys, you need some more time. All right. What did we learn today? A squared plus B squared equals C squared. Congratulations.
homework.